Hello, everybody. This is Mrs. Rainey. I'm going to talk you through the first technique. Now, the first technique is IR, infrared spectroscopy. It is the simplest one. You don't need to know anything about how these techniques work. You just have to be able to analyze the spectra that are produced. So, I'm going to read out the first paragraph just as a bit of background how infrared does work. So, infrared spectroscopy studies the vibrational properties of a molecule. The bonds and atoms present in a molecule will vibrate in different ways and at different frequencies, and these vibrations are generally quite distinct for each molecule. Each of these vibrations can be measured by passing IR radiation through a sample and measuring which frequencies are absorbed. These absorbed frequencies translate to the frequencies of a molecule's vibration. The frequency of IR radiation is measured in wave numbers, and the unit is cm minus 1. So, here is a spectrum. Now, this region round here, first of all, notice that the wave numbers go from right to left, from 0 to about 4,000. And this region here is called the fingerprint region. And this region is unique to each molecule. So we're not going to be too interested in that part. But what we are interested in is two things. So when we look at a spectrum, we're going to look to see for the presence or absence of a peak, either relating to a carbonyl, carbon double bonded to oxygen. If that's present, we will see a really sharp, intense absorption between 1,600 and 1,800. If a peak is there, we need to give the exact number that it's at. So we need to make sure that we read the scale from right to left and that we work out what each division is. The other major peak that we're going to look for, if it's there or if it's not there, is a broad absorption between 3,000 and 3,500. All we can tell from that is if there is an OH or an NH or an absence. So if we see a broad peak there, we're going to say that the molecule contains an OH or an NH. If there isn't a broad peak there, we're going to say that the molecule doesn't contain an OH or an NH. Some of the information that you'll read will tell you how to distinguish a bit more between an OH or an NH, but we're not interested in that. The other peak that we must be really aware of is the CH peak, because pretty much all of our molecules are going to have a CH bond in them, and that happens at around 3,000. So let's look at some spectra now and see what we can get from the spectra. First molecule is butane. So butane, we can see the absence of an OH or an NH and the absence of a carbonyl. So if we were talking about this spectrum, we'd say that there's an absence of a peak between 1,600 and 1,800. So there's no carbonyl, and there's an absence of a broad peak between 3,000 and 3,500. So no OH or NH. What we can, of course, see is around 3,000, we can see the peak due to the CH bond, which of course it has. Butane 1-ol. So we can see the absence of a sharp peak between 1,600 and 1,800, but we can see a broad peak between 3,000 and 3,500. If a peak is there, we are going to give the exact wave number of where it is, and we would read that from the middle of the peak. So we would read that from about there. And of course, we can see the CH stretch as well.